Welcome, everyone, and thanks for joining us. I'm Brenda Dettinger from BIOPAC, and I will be your moderator on today's webinar, Electrical Stimulation and Safety. This is a very important topic, and for those of you doing this research, we're thrilled to just talk to you about the safety issues today and teach you how to do things properly. Today's webinar is being recorded. We'll send each of you a link when the recording's processed during the webinar. If you have any questions, please submit them through the GoToWebinar control panel. That's how you communicate with me, your moderator. Before we get on to our presenters, I have an announcement. We host a biennial human physiology training event, and we've released the 2025 dates. We'll be hosting this event again in July of 2025, and it will be at UC Santa Barbara in California, and we'd love to have you join us. It's a great opportunity to get hands-on experience with all the BIOPAC devices, including the ones on today's webinar. Here's a few of my favorite photos from the 2023 event. Save the date for 4T and meet us in California next summer. Now on to our presenters. We have two fabulous speakers today. Tim Cook is a product expert and domestic sales manager at BIOPAC. He has his master's in health and human development, and he has over 18 years of experience in the life sciences and physiology monitoring industry. He's very well versed in setting up and running student lab learning systems, as well as all the research equipment, and he always has a ton of great information to share. Welcome, Tim.
Thanks, Brenda.
We also have Fraser Finley, the CEO of BIOPAC. He has over 25 years of experience in the life sciences and physiology monitoring industry. He's a well-regarded expert who presents at workshops all over the world. Welcome, Fraser.
Thank you, Brenda. Welcome, everybody.
All right, let's start with Tim. I'm making you presenter, Tim.
All righty. Okay, is that up for everybody?
Looks great.
Perfect. Yeah, thank you everybody for joining us today, taking the time out. Hopefully everybody's had a good spring semester and looking forward to summer. And as Brenda said, the main goal of this webinar is to kind of concentrate on overall stimulator safety, but we'll also be talking through the stimulator options that we provide through BIOPAC, explaining the differences between the different types of electrical stimulation, primarily voltage versus constant current, just the proper setup of a subject, and then walking through AcqKnowledge's stimulator interface itself, which is used to program everything. And Fraser will be going into depth on that. And if anybody doesn't know, AcqKnowledge is our software for data acquisition and analysis. Just a quick introduction though. Many of you joining us are likely BIOPAC customers, and so thank you obviously for joining us and learning more. But if anybody is new to BIOPAC and this is your first webinar, again, a big welcome and thank you for joining us for that. And BIOPAC has been in business for over 30 years now. We are proud to say that we're in use by over 98% of top universities, and we have now been cited over 50,000 times within the literature. And so that's something, again, we're really proud of. And so regardless of what your potential research interests are, you can always hop on PubMed or Google Scholar. Obviously, keyword search those, but add keyword search, add BIOPAC to that, and you'll find positively find a good list of reference articles that not only speak to the research you're doing or wanting to do, but to those that are currently using BIOPAC systems for that specific research. Obviously, we are going to be focusing on electrical stim, but do know that we provide stimulation of all types. So whether you're looking to do haptic feedback, thermal, visual, auditory, or we actually have a very newly designed 8-channel olfactory system for scent delivery, all those are available and they can all be tied in and used alongside eStim or in any pairing together basically. And we do have webinars that speak to all of these. So if these are of interest to your current or future research paradigms, definitely feel free to check out those webinars and let us know if you have additional questions. So diving in, what really is electrical stimulation? Basically, it is the act of sending controlled electrical pulses through the body of a subject. And that subject can be human, animal, or even tissue. Common use case scenarios for us are nerve conduction velocity, biofeedback, pain and fear conditioning, TDCS, which is transcranial direct current stimulation, and H reflex. And I kind of want to say at the beginning, and this is somewhat of my own 2 cents, but I think it's wise advice. Unlike recording, standard biopotentials such as EMG, ECG, EEG, or even, transducer-based things as temperature, dynamometry, things like that. Those are all passive signals where we're simply just amplifying what's already there in order to look at it. With electrical stimulation, we're obviously actively introducing voltage or current into the subject. So there definitely is just a larger learning curve to it, and I wouldn't just put it in the hands of any, if you are running a study and everything, I wouldn't just put it in the hands of anybody, just any undergrad or research assistant, without really thorough and proper training, because there are more guidelines and things to be aware of just to avoid any type of, harm to a subject. On top of that, there are guidelines that are in place. So the main one that most people are usually asking about and interested in is, what is the maximum amount you can deliver? And basically, via the guidelines, that is controlled. And the max amount of voltage that is allowed to be delivered is 500 volts. And honestly, none of our stimulators even go that high. But I will say that, even a shock of 100 plus is not pleasant. So the thought of 500 would, I've never been hit with anything that high, and I honestly can't imagine it. That would be quite painful. So obviously we want to stay away from anything like that. Quickly touching on the hardware that we provide for stimulation, we have a number of different stimulators available depending on just your overall need. So the first one, this larger unit over here, is what we call our Stim 100C. And this by itself actually only has a max value of 20 volts. So it does not deliver much, but it is ideal for tissue preparations, possibly needle or fine wire applications for EMG, things like that. But it is used in conjunction with our other stimulators or stimulator modules. And that's what these smaller boxes are. And what these do is actually provide additional amplification to this larger Stim 100C unit. So these units are termed the Stim ISO C, D, and E. And for example, the D has basically an amplifier in it that will multiply the 20 volts provided by the Stim 100C by a factor of 5. So ultimately, it can output a max of 100 volts. The E, on the other hand, has an amplifier that will multiply that 20 volts by a factor of 10, so outputting a maximum of 200 volts. The C, on the other hand, can not only do that, it'll do voltage up to 200 volts, but it also has a selectable current mode, and that current mode will go up to 50 milliamps. All of these, whether you're using just one or in conjunction, they all have a max pulse width of 2 milliseconds. And that's something that's very important, and Fraser will touch on that a little bit more within the setup of the software and everything. One of the other stimulators we provide is termed the Stim ISO LA, and this is by far our most versatile amplifier, versatile stimulator. But with that versatility comes kind of an increased risk, so there's an increased need to be aware of that and I guess use it with increased caution or increased care. This stimulator can actually operate in both voltage or current mode. There's a little selector switch over here, so if it's slid over to the V, that will be voltage mode. Slid over to the I, that would be current mode. And you have two output interfaces. So you can either interface an electrode that connects via B and C, or just standard touch-proof electrodes that then run to either individual spot electrodes or even like a larger patch electrode, just depending on what your stimulation protocol calls for. So this will actually, again, it's a little bit more unfettered, and this will go up to 400 volts on the voltage side or up to 100 milliamps of constant current. This also can provide, instead of just being run off of and providing more simple stimuli such as square waves or sine waves, this can run arbitrarily long and constant and non-varying, basically, output currents, which are needed for TDCS. So if you're looking to do TDCS, this would be the amplifier that you'd want to employ for that. And along with that, we do have a couple kind of like additional pieces of hardware that can be applied to that. For TDS specifically, the cable limit 2 is a really good safeguard because there's a potentiometer in here that is brought in line with the stimulator, and basically it limits the current output to a maximum of 3 milliamps. So regardless of what you do, even if mistakes are made on the software end and you would put something at too high of a level, this is just a safeguard. So no matter what is done on your end, it will never exceed a max of 3 milliamps, which obviously is very important for TDCS. And then the cable CFMA, this basically allows you to run the output from the stimulator back into our data acquisition system, so you can actually record the stimulus that's being delivered into the physiological file, so you have a record of everything. Now, if you don't have a stimulator, if you're, either you already have an MP150 system or an MP160 system, and you need a stimulator setup, or if you're looking to get started with everything from scratch, we do have turnkey kind of quote unquote kits that provide everything you need. So it's just a matter of getting that, and whether it's outside of the MRI, like this system and this potential setup here would be for use outside of the MRI, whereas this package would be for use inside of the MRI. And there is a difference. So do know that, for example, this Stim ISO LA, we do not recommend that being used in an MRI. So not everything is interchangeable. So if you are going to be working within an MRI environment, please contact us and we'll obviously help you get everything that's necessary in place for the safety of your participants. Oh, the one other thing I wanted to mention that just occurred to me, with this, one of the other benefits of the Stim ISO LA is that it can be driven by any analog signal. So it's not limited to having to work with our data acquisition system. So basically, whether you're using, if you're using like MATLAB, for instance, even ePrime, LabVIEW, as long as it can drive an analog output, you're able to use it with this stimulator. And with that, we will jump back to Brenda for our first poll.
Hey everyone, thanks so much, Tim. I will go ahead and launch our poll. Okay, Tim, stop sharing your screen because I can see the videos.
Oh, I'm sorry. I'm sorry.
That's okay. I'm gonna go ahead and launch our poll. All right, and hopefully you all can see that. Sorry, we're on it. Oh, there we go. Great. All right. So are you currently using electrical stimulation? Now, I did have a question from the registration process from a registrant, and it is it possible to record the stimulus with my response data?
Yes, absolutely. Again, as long as you have the cable CFMA, that's what provides that feedback. So very, very easy way to do that.
Okay. Great. And just so you all know, we do have an ability for you to ask questions live. I see some questions coming in. So we'll get to those in a little bit, either at the end or as many as we can throughout the presentation. Okay, I'm going to go ahead and close this poll, and I'll share the results with you all. It looks like almost 3/4 of the people are currently using electrical stimulation. A super small percent are not using it yet, and then another batch of 17% are wanting to use it in the future. So thanks all for participating. I really appreciate this. Now we're going to switch gears, and I am going to make Fraser the presenter.
Thanks, Brenda.
There you go.
Perfect. Thank you. Okie dokie. Okay, so Tim's talked a little bit about the different types of hardware and the importance of safety. I think from most perspectives, you're going to gain safety through familiarity with the equipment. So I wanted to spend a little bit of time walking through and explaining the user interface for the AcqKnowledge software stimulator module. This is all controlled under the MP menu, under the MP 160 menu, Setup Data Acquisition. When you open this dialog, there's an option on the left-hand side for Stimulator. By default, it opens up to allow you to set up the channels that you're going to collect data from. But select Stimulator and it takes you into this user interface. And again, when you first come in, the default, it will be set to square wave, and there's a default option there. The way the MP160 is designed, it actually has two analog outputs, analog output 0 and analog output 1. These are completely independent of one another, so you can drive two stimulators simultaneously. So you can have two completely independent paradigms or two completely different types of stimulator that are being controlled from either analog output 0 or analog output 1. If you look at the front panel of the stimulator, and I've got a picture of the front and the rear panels here, and I will enlarge that so it's a little bit easier for everyone to see. And there we go. So this is the front panel of the STM ISO LA. This is the unit that I'm going to be using today in conjunction with an STM100C. But on the front here, you've got the ability to run in two modes, either voltage or current. You can connect different types of stimulating electrodes, either using touch-proof or BNC connector. On the rear side, you've got the cable that is going to drive the stimulator. So this end will plug into an STM100C, but it can also connect to a third-party device. So it doesn't have, this device can be used standalone with third-party equipment. And then there's the power socket on the back. You've got the reset and test. But this basically is what the stimulator looks like. And if I come back over to my user interface, if I've got the device connected to analog output 1, these are connected. If you look at the front, this is an MP160 on the left. In the middle is an STM100C, and on the right is an AMI 100D. But you may have a HLT 100C or a UIM 100. Now, at the bottom of all these devices, you've got two analog outputs, analog output 0 and analog output 1. On the STM100C, you can select which of these two, 0 or 1, you're actually going to use to drive the stimulator. So this is the STM ISO-LA. This is connected to the STM100C. And I'll get into that in a little more detail. But I think it's important to understand the difference between these two analog outputs. Now, the stimulator and the software can be controlled to output continuously, or it can output just once. So if the way I've got this set up, I've got it set up using the user interface down below so that I've got two pulses, and then I can output these continuously. So these are 500 millisecond intervals, my interpulse interval, and then my pulse width is 0.1 milliseconds. So it's a very narrow pulse width, and I've got this set to 10 volts. So the analog output signal that is driving the STM ISO-LA, the maximum we can output is 10 volts. And that will allow you to stimulate it up to 200 volts. The multiplication is 20 times the input signal. And then the STM100C has a dial on the front, which I'll show you, that allows you to increase from 0 up to the required level. So if I want to adjust my pulse width, I can either enter it here, and now we can see this first pulse, we've increased this pulse width, or I can drag the active component over. Okay, now this is where you can get into some hazardous situations. You want to try and keep your pulse widths relatively narrow if you're doing things like nerve conduction or muscle stimulation. So always pay attention to this. Some of our stimulators will control the width. They will naturally reduce the width so as not to give too sharp of a stimulation to the individual that's receiving the stim. Okay, so this user interface can be controlled at the top by dragging, or you can control it through the dialog down here. You can also control the sample rate of the signal that is being output, and that is independent of any signal that you're collecting. For example, if you're only recording relatively slow signals, you can have your data acquisition sample rate much slower, but if you're sampling quite rapidly, you can increase that sample rate here. So you've got independent control of the analog outputs versus the data acquisition. Down below, you've got some controls here that will allow you to start data collection and then automatically initiate your stimulation. So the way this is set up at the moment, if I start to record data, this square wave that appears at the top will be output immediately we start the data collection. But if you don't want to run it that way, you can use the manual control setting, and then down below you've got independent control of these two, analog output 0 and analog output 1. So I can start and stop my stimulator independent of my data acquisition. For the moment, I'm going to use it in this mode. I'm going to get rid of PowerPoint for the moment. So in the background, I'm just going to make some changes here. All right, so I've just reset this all the way back to 0, and I'm going to make some adjustments so that we can see two things on the screen at the same time. like so. Alrighty, so if I set this to use manual, I can then sort of start collecting data and control what's going on over here independent of the data collection. So let's just take a look at a couple of other things that I'm doing here. One of the nice things I think when you're familiarizing yourself with the equipment, if I bring this back over so that you can see this, this is the setup. I'm running a cable, a feedback cable that is coming from analog output 0. It's kind of just going off of the screen a little bit, and it's coming into channel 9. And anything that comes out of the analog output will be recorded and displayed on channel 9. So if we come into channels quickly, you can see I've got channel 9 set up over here. So just very simple. It's a loop back cable. But again, if you're designing your stimulus paradigm and you want to familiarize yourself with the performance of this, it's highly recommended to do that. So let's take a look at how the stimulator performs. If I start recording, okay, so we can see we're not collecting any data at the moment, but if I turn my stimulator on, immediately we can see we've got our waveform. Okay, this is the same square wave, is set to 10 volts. If I adjust my scale, we can see it's actually bang on 10 volts. So that's being controlled here, 9.9999969. I also have the ability to start and stop this as many times as I want, but there are different output options for the stimulator. So I can change this to output a sine wave. Okay, and if I turn this on, now we can see we've got this sine wave, which is running between plus or minus 5 volts. And the same user interface over here allows me to make adjustments the same way I did with the square wave. Again, if I pause this, we've got the ability to add a ramp. So now we can ramp any form of stimulus up. And again, you can control the time window that this appears over. So let's make this longer, turn this on, and we can see we've now increased the time period in which this ramp is increasing. And then lastly, we have the ability to create arbitrary waveforms. So an arbitrary waveform can be any waveform that you have previously recorded. So I've used one of our sample files from AcqKnowledge, and I've got it just over here. So I've just used a small segment of it. Down here, any waveform that you have, any file that you have open, you can select that file. So this is the file that I want to output. When I turn this on, we'll now start to see the ECG being output from the stimulator control. Now again, this can be set up completely independently of the two. So I could have, for example, if I leave this turned on, I've got this arbitrary waveform set up over here, but actually let's come into analog 1 and let's turn this on. All right, so now on analog output 1, I've got this square wave on, and I'm going to turn them both on. So at the moment, they're both outputting. I'm only seeing one, but if I switch my cable over to the other output, we'll see the sine wave from this second one, and I can stop that independent of analog output 0. And if I connect this back over, we'll see that we're still continuing to output that waveform. So these two outputs can be controlled completely independent of one another. So the purpose of showing you this is to, help you understand the things that you can do, A, within the AcqKnowledge software, but B, to also encourage you to play around with it. If you're just using a feedback cable, you've got no one connected, you're not going to harm anyone, you can't harm the system because the analog output values are low level. And then you get to play around and become a little bit more confident with how the stimulator is controlled from here. Once you feel quite confident that you've got the paradigm dialed in, you can then transition that over to an active participant and know that you're not going to, unintentionally shock them in a way that is undesirable. So sort of too much, too soon. Okay, well, that gives you an overview of the stimulator setup. I'm going to hand back over to Brenda, and then a little bit later on, we'll take a look at how you actually use the stimulator to deliver both constant current and constant voltage stimulation types. So Brenda, I'm going to hand back over to you for our poll.
All right, thanks, Fraser. I'll go ahead and launch the poll. And now we're just looking at what your application area is. It's always a great information to share with us. And then while that poll is running, let me just let you know that I did have another question about stimuli. Can I have more than one source of stimuli, Fraser or Tim?
Yes. Yeah. So through analog output 0 and analog output 1, you can have two completely independent outputs. So one could be a square wave, one could be a ramp, and they can be controlled independent of one another. And in fact, if you want to stimulate multiple people at the same time using the same paradigm, you can also do that. You can have multiple stimulators as well as two completely different outputs. So if you've got three people and you want all three of them to receive the same protocol, you can have three STM100Cs and you can have three STIM-ISO-LAs, and they will each output exactly the same signal. So you've got combinations. You can have independence and you can have multiple people receiving the same form of stimulation.
Okay, great. Thanks. All right, looks like it's a great mix of people doing all the different application areas with a little bit less of biology, and everyone else almost equally spread across the different application areas. So thank you all for responding to that poll. Now we are going to head back over to Tim, who will talk more about platforms.
Perfect. Okay. Well, not so much platforms, but more safety. I think Fraser will be getting into that. But as far as, again, I would say the number
Tim,
one
let
safety
me
rule.
interrupt you for a second. Can you
Oh, shoot.
maximize
Yeah,
your
there we go.
screen? Yeah.
Sorry about that.
All right, there we go. Thanks.
Yeah. So I would say the number one safety thing to be aware of is that when we're applying a stimulus, especially obviously electrical, either voltage or current to somebody, I never think about it as just applying the stimulus to the entire body. We're always providing the stimulus to a specific point on the body. So hence you would never just put one electrode on, the right shoulder and the other one on the left shoulder, or right leg, left leg. They're always going to be on the same side of the body. And the reason for that is we never want to pass a voltage or current across the axis of the heart. That would probably be the most dangerous thing that you could do. So whether you're using spot electrodes or patch electrodes, they're always going to be placed on the same side of the body. Again, as Fraser mentioned, you're always going to want to start with a low level and gradually work up to the desired level of stimulation. Because, to be honest, most people coming into a lab as subjects have probably never been hooked up. Most people haven't and received electrical stimulation. So it's not something you just want to right out of the box hit them with, 50, 60, 70 volts. If you do that, I think you're going to have a lot of participants just ripping things off and walking out and not being willing to participate. So you always want to gradually work them up and introduce them so they're aware of what to expect and know what it's going to feel like, basically. It's also smart to remove just rings and jewelry. And then I would say that the other very important thing in terms of all of these is to use electrodes that stay in place. Something with a very high tack electrode that has a good adhesive on it. That's not just gonna either be pulled off by accident or slip off by accident, or even something that can't be pulled off very easily. So obviously the larger patch electrodes work well for that because they do stay in place really nice. But if you are using individual spot electrodes, if you're getting them from us, basically I would, go with one of the 500s, 501, 502s that have a nice, really tacky background, tackiness to them that are going to stay in place better. Now, Ohm's law is kind of the guiding principle, and we're not going to go into super in depth on this, but it's just kind of good knowledge to have, of course, and most of you are probably aware of it. But basically, voltage equals current times the resistance or impedance, interchangeable resistance, aka impedance. So whether you're stimulating in voltage or current, both are actually present. They're always together. You're never just using them apart from each other, of course. And obviously the resistance or the impedance is inherent in everything, and it's basically just the material's tendency to resist flow, or the flow of a charge, of course. 99% of the body's resistance to electrical current flow is at the skin. So as an example, a callous, dry hand may have more than 300 ohms of resistance. Whereas once you get through the skin, obviously we're pretty much made of water, so the overall resistance is extremely low at only about 300 ohms. So it is very important to do proper skin prep because we truly can't do a whole lot to control impedance other than proper skin prep and doing everything we can to not only decrease the impedance overall, but to keep it consistent throughout the course of the experiment. And it is important in terms of electrode placement. You'd never want to put electrodes over any type of injury in the skin, be it a cut, a burn, or anything like that. That would generally have a much lower resistance, and so it could obviously really cause pain or additional damage. Now, probably the biggest question we do get is what to use. Do you stim using current or do you stimulate using voltage? And I generally tell people that that's not really our role to determine for you in terms of methodology. It really is important to dive into the literature for your specific application and see what is used most commonly and what the constraints are and everything like that. And then if we're fed that information, basically we can then help you set up the hardware that's going to allow you to carry that out. But I kind of shy away from saying what's better than the other. I will say that having worked for BIOPAC for 20 years and doing STIM outside of that, even prior to coming to BIOPAC, the vast majority of people do seem to use constant current. And to quickly get into the pros and cons of why, regarding both voltage and constant current, with voltage, the biggest pro is that it is considered a little bit safer. You don't have the current density buildups that can happen, and so it's a little bit less at risk of providing an aberrant shock. The biggest con, however, is that you can't guarantee the same level of stimulation every time. So if the impedance does change a little bit at the skin, you can receive a little bit higher or lower voltage output. It's not going to be, if you have it dialed in for a 30-volt shock, it's not going to be 20 once and 40 the next, but it's not going to be exactly 30 every time, basically. Whereas with constant current, that is the biggest benefit, is that the exact amount of current will be delivered at all times. And that's nice, but it does carry a little bit of inherent risk to it, because what can happen, and what we see most commonly happen, is if an electrode starts to peel off, the voltage required, so let me start over. So if an electrode starts to peel off, that's going to cause an increase in resistance or an increase in impedance. To hold the current constant, the voltage needs to increase. And if the electrode is then put back in place, you'll get an immediate drop in the impedance, and the extra voltage that was required to keep the constant current needs to dissipate. And obviously the only place it can dissipate is through the electrodes, and that's where the aberrant shocks come into place. So it's very important to make sure that the electrodes do stay in place, and keeping the impedance as level as possible. I think I did an okay job of explaining that. I hope so. If you have questions, please make them known. And with that, then we'll go back into our last poll, and then Fraser's going to dive into some more hands-on stuff.
Okay, thank you. Let me go ahead and launch that last poll. And here we go. If you're performing electrical stim, what technique do you use? Lots of you have said that you were performing, so this will be interesting to see if Tim's data mirrors the data that we're going to get in this webinar, where most people do constant current. It's looking like that so far. All right, well, let me ask this other question, Tim. Can you deliver trains of pulses and or arbitrary waveforms?
Yes, absolutely.
Okay. All right, so let's just see how many people are voting here. And it looks like we're pretty close. Let's see if we'll give it another 20 seconds or so. Yeah, looks like 56% of people constant current, 18% voltage, 21% both, and 8% doing other forms of stimulation. So thank you all for participating in that poll. And now we head back over to Fraser. So Fraser, I'm making you presenter.
All right, thank you, Brenda. Excellent. All right, well, thanks, Tim, for all that information. What I'm going to do is put some of that in practice right now, and let's see if I can change my display. There we go. So I'm going to essentially use the same paradigm, but Tim identified some key points there, and those I think we tend to overlook a little bit. It's sort of a common thing. We obsess a lot about electrode preparation and subject preparation when we're collecting biopotential signals, particularly if you're collecting very low level, small signals such as spatial EMG. We always want to make sure that the impedance is as low as we can possibly get at. Well, the same applies to stimulation. one of the things that can happen when you're using electrodes that haven't been, and the electrode site hasn't been correctly prepared, you put the electrodes on and the impedance changes over time. And if you start off and you ask the person how painful the stimuli is, or you're relying on setting a threshold, after the electrodes have settled on the subject for 5, 10, 15, 20 minutes, the impedance will drop down because the gel is making contact with the skin and we're just changing that resistance. So the downside to that is the initial high impedance level means you need more voltage or more current to actually stimulate the individual. But over time, as that drops down, the same voltage or the same current can actually feel different to the participant. It can feel much, much more painful just because the electrodes have settled down. So what we recommend is your electrode site for stimulation should be treated the same way you would treat a recording setup. So we use either the prep gel that's slightly abrasive or the abrasive pad. So this is one of the L pads. I have my camera on so I can't see whether you're seeing me. Let's come back over here. Yeah, here we go. So these are the L pads, and they're just very simple. If you're used to using them for ECG or EMG, any biopotential signal, you just abrade the site of the skin that you're going to apply the electrode to. And then for stimulation, we use gel 104, which is a salt-free gel. And we recommend, if you're applying the electrodes, these are very nice peel and stick. These are the 509s, come in an envelope like so. These will work both inside the MR environment as well as outside. They arrive dry. They do not have any gel on them. The sponge pad in the center is completely dry. Nice thing about that is you can be a little bit more relaxed about how you store them. A lot of the times we're always telling customers, make sure the moment you've used your electrodes, there's a little Ziploc along the top, seal them up, put them away, otherwise the gel dries out. Well, with these, you don't have that problem. You basically peel one of the electrodes off, get some of your gel, and all you're looking to do is just apply about a pea-size amount of gel in the center of the electrode. There you go. Hopefully you can see that. So you don't want to swamp the electrode, because what tends to happen then is when you apply it to the subject, the electrode squeezes out and it gets over the adhesive part. And then the electrode just doesn't want to stick on the subject. The good thing about these 509 electrodes, they really adhere really nicely. So once you've got them on, they're in place good and proper. The other thing that we recommend, particularly, really for any lab, is the L check. If you don't have one of these, I would say this is one of the must-have tools. So no matter what type of electrode recording you're making, whether it be recording biopotential signals or stimulating, this is a super important tool. This is going to let us know what impedance level we're measuring at the electrode site. On the one end of the device, we've got a row of touch-proof connectors and the same connector that we use for our Bionomatics wireless recording systems and D-series amplifiers. So if you've got C-series amplifiers or you're doing stimulation, you use the touch proof. If you're using our wireless bionomatics or the latest D-series amplifiers, you'll use this connector here. On the front of the device, you've got options for the positive, negative, and ground inputs. And I just dropped my electrode lead, so pick that up. I'm going to connect these between the plus and the minus. Where's the other one? Here it is. Okay, so I've got these connected between the plus and the minus. And if I hold that up, I'm not sure how well this camera will pick it up without the glare. There you go. So this is looking between the plus and the minus, and I've got two electrodes connected to my arm. And all you do is you just push the button in the center and the LED will light up. And again, hopefully, if I get that just right, you can see. That's green, that's the lowest impedance level. That's what we're looking for. Okay, so these electrodes have been on for probably 45 minutes now. So once we know that our impedance levels are good, we're then ready to connect everything up to the system. Now I'm going to set this up so that I'm going to record I'm going to record constant current. I'll put the other camera on in a moment. Okay, so let's have a look at what we've got going on over here. So if you remember before we went into MP160 and this dialog opens up. Now what I'm using is the current feedback cable. This is the cable that Tim talked about. In constant current mode, we can feed back the signal so that in real time we can see exactly how much current is being delivered to the participant. And it's a loop back cable, and if I bring my camera over, okay, so you can see on the front I've got the electrode leads connected to the plus and the minus on the stimulator. This part here, if I move this over a little bit, is the feedback cable. And you'll see that there's a loop. That one part of that loop back cable comes into this device here. This is the in ISO. So this provides optical isolation on the input side. So there's no chance of any stray shocks being passed through to any other channels that you're collecting data. So if you're collecting response data, physiological data, there's no chance of any aberrant shocks occurring there. So the in ISO is important. We've got the cable feedback coming in, and that is connected to channel 1. So again, if I bring this back over, this is this cable here. This is the in ISO connected on analog input 1. Now in terms of the stimulator, I'm using that paradigm that I had set up earlier. So this is just going to continuously output a square wave of 0.1 milliseconds with an interpulse interval of 500 milliseconds. And the moment, and I'm going to turn this, it's a good rule of thumb, always make sure that you turn should come over here and show you this. Just here is the output control. So this allows the technician to control the voltage and current that is being delivered to the participant. So you always want to make sure that that is in the 0 position. Otherwise, the moment you start recording, the person's going to receive a nasty shock. So when I hit start, you can see, and if I bring the video over, you'll see there's nothing going on the stimulator, and we're not seeing anything coming through the feedback cable. But as I start to increase this, we can now start to see the red LED on the stimulator is indicating that we're actually outputting. On my feedback cable, we can see that we're actually outputting current. And I'm going to change cameras again quickly so I can see what you're seeing. So if I stand up here and hold my hand, you can see I'm triggering my hand. Maybe get a better view from there. You can see this finger, I've got it right on the finger. And if I turn this down, that's it. And then as I increase, you can see that. Okay, so at the moment, I'm actually not recording the response. It's just more of a visual indication of what's going on. But if I connect, if I stop this, and I come back over here, if I come into channels, smart amplifiers, make sure I've got my device connected. Okay, so I've got do that again. Getting everything set up here. And I'm just going to put these electrode leads on. All right, so we've got an EMG amplifier connected to channel 3 now. And let me show you what that looks like. So I've just got some ground on the back of my hand, and I've got the electrodes connected here. So now when we start collecting data, here we go. When we start collecting data, we'll now see this channel 3 will start up. So let's start over here. It wants to replace or abort because I've added a new channel. So I'm just going to say replace. Make sure we've got this turned down. Okay, so at the moment there's no stimulation being delivered, but as I increase this, we can see already on the red channel and down below we can see the response being picked up down below. And if I stand up, hopefully you're able to see that. I'm going to close this out so I can see what you're seeing. There you go. Again, if I turn this down, we can see that stimulus go away. So that's one mode of stimulation that we've just looked at. I'm going to close this, and I'm going to remove these electrode leads. Next, I'm going to show you constant voltage and a different type of stimulator. And I kind of like this stimulator. This one was designed originally for our teaching system, but it's really very, very forgiving. I'm going to turn these, remove these other recording electrodes. So this electrode here is the HSTM01, and if I get the other end of it, this one connects via BNC. So I'm going to connect this to the front panel of the StimISO LA. You've got the two electrodes, positive and negative, but the thing that's really nice about this particular one, it's got some extra safety features in there. It will reduce the amount of power that can be delivered to the individual, and even though we may be continuously delivering, until we push the button down, the participant won't receive any stimulation. One of the nice things I like about it is when you're doing nerve conduction, it can be a little bit tricky to find the exact right spot. So this device is really good for that. You can abrade the surface of the skin, apply some gel, and then use this to move around in order to find the correct location. So I'm just going to set this up, make some changes here. Disconnect these. And again, I'm just going to abrade the skin. And I'm doing a much larger area this time. So this is, a good way to try and find the activation point that you're looking for. Just get a little bit of gel, apply it to the place that you're going to stimulate and that you've just abraded, rub it around a little bit. Change that to voltage. Actually, have this connected, and where's my setup? So I'm not going to be seeing anything on the EMG. I just disconnected those for the moment. But now if we hit start, okay, I'm going to hide that channel there because I've got nothing connected to it. Hold on a second, I need to reconnect something over here. And I'm going to set this up because I'm doing voltage. I'm just going to make some quick changes here. I've got this set up so that I'm connected to this channel here, and I'm not using the feedback cable anymore. I'm just going to be putting in a voltage signal, and now I think we're ready to start stimulating. All right, perfect. Okay, great. So give me 1 second. Okay, so I think I've got everything. Yeah. Okay, so if I'm holding, let me minimize this. Okay. So all I'm doing is I'm applying this and I'm just holding the button down. But at the moment, I'm not giving much power, but I'm just going to increase this. And now I can feel that and I can see my hand twitching. And all I'm doing is I'm just moving this around until I've got the point that I'm interested in. And that's one of the nice things. If I move this around, there you go. Now I've just got that finger. If I move back the other way, I'll lose that. I start to get more of the whole hand. Now I'm on the little finger. So the nice thing is with this one, it allows you to try and locate the exact spot. Once you've found that spot that you're looking for, you can mark it, dry off the gel, and then apply electrodes permanently. I'm just going to increase that a little bit more. So that's, two different techniques. One, this is voltage that I'm using. Originally, I was using constant current. Very similar setup, just that voltage, this electrode gives you a lot of freedom to move it around. So Brenda ran a little bit long there. I'm going to hand back over to you for some questions, I believe.
Great, Fraser. Yeah, yep, here we go. All right, thanks so much. So I do have some questions. Let me go ahead and share my screen here. Okay, one sec, let me just get this up. Okay, so yeah, so we had a few questions actually. I don't know if I'm going to pronounce this name right, but Ibrahim asked if the device offers mono or biphasic stimulation.
Yes, it will do any form of waveform, the stim ISO LA, so it can be completely arbitrary.
Okay, great, thanks. Alexis asked, safety question, should we screen people for pacemaker and other heart issues prior to use?
Yes.
Okay, great. And in the last example, so Sebastian just asked, in the last example, looking for the right spot to apply stimulation, did you use bipolar setup? Was there a second reference electrode?
For the stimulation, it's just 2 electrodes, positive and a negative. And then for the recording of the response, we put a ground on the participant. So I had the ground for recording on the back of my hand, but for delivering, when I was using the constant current, I just had 2 electrodes, one for the positive connection and one for the negative.
Okay, great. And then since you used a BSL stimulator, Faisal asked if this could be done with an MP36 using BSL, and I'm guessing the answer is yes to that.
Well, no, not exactly. Yes, you can do stimulation with the MP36. You can do constant voltage, and the stimulator is similar on the MP36 system, and you use this same electrode. So yeah, you can do stimulation, but it's going to be voltage only.
Okay. And then Sebastian asked a follow-up question. He said the plus and the minus were both in the same device that you moved around, question mark?
Correct.
Okay.
Yeah, there's two electrodes on there.
Okay.
One is the black and one is the white.
Okay, hopefully that helps. Yep, he said thank you. And then is there any voltage loss when splitting off using that current feedback cable? What amount of the current is lost going to the recording system versus going to the subject? Is that measurable or negligible?
Negligible.
Okay. And then I'm not sure about this one. So do you recommend current or voltage controlled FES for stroke rehabilitation? That came from Kai.
I would probably defer to the literature on that and see what's recommended. I think current is used in a lot of instances, but I would want to refer to that.
Okay. All right. Well, thank you very much. I do have some closing comments that I want to share with you. Well, first of all, I just want to let everybody know that on our website, we host all of our webinars are listed. So past webinars, future webinars. We do have a webinar coming up. I'll tell you about that in a second. You can just visit our website at biopac.com /webinars to access any of our webinars. And if you'd like to reach out to your regional representative, we have regional reps all over the world. You can just scroll down to any page of the website and fill out this form. Mine is Amy because I'm in California, and this will send an email directly to your local representative. So I also want to let you know our next webinar is June 12th, and we're going to be talking about EDA, getting started with some of the main basic signals. So EDA, ECG, EMG, and respiration. I think we've got a little pulse thrown in there too, maybe. And so you could just see some samples of other webinars here on this slide, but also we'll have this June 12th webinar up on our website early next week after the holiday. And if you're interested in attending a workshop in your area, we do host workshops all over. We travel to you. You can host something at your institution, and you can invite your colleagues or people from other institutions in your area. It's been very, our customers have been very happy to have us come and do some training on site. This is one with our new MetaLab system and VR, but we've done them on a variety of different topics. So if you're interested in that, you can reach out to your local representative or go to this link right here to host a workshop. And finally, I just want to take a minute to thank our presenters. Thank you. Thank you for this great topic and all the work that you've done, Tim and Fraser, to prepare for today's webinar. I know it's a lot of work to prepare for these things, and I know you had to stim yourself, Fraser. So thank you for taking the hit on that. And I want to let everybody know that today's webinar was recorded. We'll email each of you a link to the recording and eventually the slides. If you had any questions we couldn't answer, we'll have your reps follow up with you. When you close the webinar window, you'll see a survey. Please complete that so we have your feedback and ideas. And feel free to visit biopac.com for additional references, including screencasts on specific features, application notes, and of course, information about upcoming webinars, events, and past webinars. We have a flurry of events that we're going to right now. We're at HAPS, APS, ACSM, and a bunch of other conferences in Europe. So come by and see us. If you are in the neighborhood, if you're at a conference, come by and say hello. Speakers, anything else before we conclude?
I think so.
I was just going to say, Tim may have mentioned this, but there is a great application note on our website that provides a lot of useful information about safety as well. So direct people towards that. If you go to the support section and applications, you can look that up.
I can show you right now support and then application notes here. And then what would I type in? Simulation. Whoops, I just spelled it wrong. Okay, well, stimulus isolator guidelines and some other things, safe use of electrical stimulators. So great. All right, well, that is a wrap. Thank you all for attending. And thank you again, Tim and Fraser. This concludes today's webinar. Have a great rest of your day, everyone. Bye.
Thank you. Bye.
Bye.